Here's a video that will help you with the sample calculations that you need to do for your milk of magnesia lab, or the empirical formula of magnesium hydroxide by titration. You collected your data, and in my trial, my data was that I used 6.05 milliliters of milk of magnesia, and my initial volume of the 0.84 molarity HCl was 1.62 milliliters, and my final volume of HCl was 20.70 milliliters. The first thing your sheet tells you to calculate is the mass of magnesium hydroxide in the flask. To do that, you start with your volume that you used, 6.05 milliliters of milk of magnesia, and of course that'll change depending on what you used. And then this is where we need to use the ingredient label, and we know that there are 1,200 milligrams of magnesium hydroxide, the active ingredient, per 15 milliliters of the milk of magnesia. So that gets us to milligrams of magnesium hydroxide, but we need grams of magnesium hydroxide. So to cancel out milligrams, I know that in 1 gram there are 1,000 milligrams. So that will leave me with grams of magnesium hydroxide. And if you punch in all your calculations, and I'm going to assume that these are exact numbers because it's on a label, so I'll go to 3 significant figures, and I'm going to go with 0.484 grams of magnesium hydroxide. So that's the first thing you have to calculate. A minor calculation you may have already done is the volume of HCl added. Here you just do your final volume minus your initial volume of HCl to get your volume added. In my case, my final volume was 20.70 milliliters. My initial was 1.62 milliliters. And so my volume of HCl added was 19.08 milliliters. And you may have already done that. Now, moles of HCl used. This is a new one for us. This uses the concentration or molarity. You start with your volume of HCl used. In my case, it was 19.08 milliliters. And here's where we use that concentration. 0.84 molarity means there are 0.84 moles of HCl per liter, or 1,000 milliliters. So the milliliters of HCl cancels out, and you get moles of HCl. Going to 2 significant figures, this is an exact number and this has 4, so we'll go to 2 significant figures. This works out to be 0.016 moles of HCl. After moles of HCl used, which is the first line in section B, results, you need to figure out moles of OH, which is your hydroxide. Moles of OH is related to your moles of HCl. Start with your 0.016 moles of HCl. And page 1 of your handout, or the directions for this lab or the background, tells you that there's 1 mole of OH for every 1 mole of HCl. It reacts in a 1-to-1 molar ratio. So really you just also have 0.016 moles of OH. This is from page 1 of the handout, this ratio. So that was pretty easy. Mass of OH comes next. It's kind of nice that it walks you down the line in order on the report sheet. You'll just get this from your moles of OH. So if you have 0.016 moles of OH, use the molar mass of OH. In 1 mole of OH, you have 17.01 grams of OH. This comes from O being 16 and H being 1.01 for your atomic weights. Your moles cancel, and you will end up with, again to 2 significant figures here, about 0.27 grams of hydroxide. The mass of magnesium comes from this little formula. You take your mass of magnesium hydroxide minus the mass of your OH that you just found, and that will equal your mass of magnesium. Well, the mass of magnesium hydroxide was from up above, the 0.484 grams. The first thing we calculated. And the mass of OH we just calculated here, 0.27 grams. So that means the mass of magnesium is 0.21 grams. And again, with this is 2 decimal places and this is 3. You have to go to the least precise, so this would round to 0.21 grams. Your moles of Mg comes from your mass of Mg. 0.21 grams of Mg. Do a little mole calculation. 1 mole of Mg is 24.31, I think. We'll just call it 24.3 because this only has 2 sig figs anyway. Grams of Mg. And that ends up with 0.0086 moles of Mg. So you had to do all of this work because now we will have moles of magnesium, and up here we have moles of hydroxide, and that's what we need for our empirical formula calculation. Remember, your empirical formula is Mg something OH something, and again that's a group, so I'll just put in parentheses for now. Well, my moles of Mg was the 0.0086, and my moles of OH, and I'll zoom in here, is 0.016. And if you divide by your smaller number, which in this case is the 0.0086, you'll get Mg1 OH like 1.86 or so, which I'm going to say is close enough to 2. So I'm going to say it's MgOH2 would be my empirical formula. That's the actual formula of magnesium hydroxide also, because magnesium has a +2 charge and hydroxide has a -1 charge, so it works out to balance the charges that way. However, don't be surprised or sad if you get a different formula. Really, I'm just following your calculations through and seeing if you carried those out correctly. It depends on how carefully you were able to titrate and measure things in lab. I've seen things from Mg3OH to like MgOH9, lots of different answers, but it'll all depend on your measurements and calculations. I hope this video helped.